If we have 3 points that are not collinear, then those 3 points form a triangle by just connecting the dots. So draw any old 3 points, we can connect the dots and get a triangle. And that gives us the name of this property of the Euclidean plane. If you give me any 3 random points, A, B, and C, then the distance from A to C is less than or equal to the distance from A to B, and then from B on to C. So if we have 3 points A, B, and C, the distance from A to C is less than or equal to the distance from A through B and on to C. And they're only equal if B is actually on the line segment, so they're only equal if they actually are collinear. We sometimes phrase this property as the shortest distance between 2 points is a straight line. If I have some distance between A and C, I can't get there faster by going through B. And so that's another property that characterizes the plane. And it's primarily interesting to us if AC is the longest of the 3 line segments. Because of course, if one of AB or BC is longer than AC, well, of course this sum is going to be longer than AC. So it's really primarily interesting if AC is the longest of the 3 line segments. To practice our understanding of this inequality, we sometimes ask whether a list of 3 numbers are possible sides of a triangle. That is, possible lengths of 3 segments AB, BC, and AC. Now this is not a problem that we will necessarily encounter in real life, though it is a way of detecting that we've made an arithmetic mistake in finding some lengths. This is mostly something that we're doing to practice our understanding of this inequality. But we're going to check, are the 3 lengths listed here possible lengths of the sides of a triangle? So here, in this first example, our longest side is 10. So we want to check, is 10 less than or equal to the sum of the other 2 sides? The lengths of the other 2 sides are 5 and 6. So we want to know, is 10 less than or equal to 5 plus 6? Well, this is 11. So yeah, that's true. So yes, we could possibly have 3 points, A, B, and C, so that AB is 5, BC is 6, and AC is 10. What about here? Well, BC is now my longest side. So I want to check, is 6 less than or equal to 1 plus 3? Well, that's 4. So no. 6 is greater than 1 plus 3. So those are not possible side lengths of a triangle, which means that if I actually have AB, BC, and AC, and I figured them out and I think they're like that, either I'm not in a plane or I did something wrong. This can't happen for any 3 actual points. This is impossible. So it's not just that, oh, this is not a triangle. It's, if I have 3 actual points, A, B, and C, those cannot possibly be the lengths that I get. Okay. In this example, AC is my longest side again. So I want to check, is 8 less than or equal to 7 plus 5? Well, that's 12. So yes. Again, these are possible side lengths of a triangle. And let's see. Here, AC is my longest side again. 6, I want to know, is that less than or equal to 4 plus 2? Well, that's 6. Those are equal. So, well, I mean, Kinda? It depends on what we mean by triangle. If by a triangle we mean an actual triangle, then no, this is not a triangle. Because these are equal, we know that these points are collinear. It is possible to have three real points like this. They'll look like this, approximately. But I wouldn't call that a triangle. That's a line segment with an extra point on it. So these are possible distances, but we wouldn't really call it a triangle. We might call this a degenerate triangle, or just three collinear points. Degenerate means it kind of has some of the properties, but it's certainly not what we'd think of it as.